All right. So now we reviewed lines and then we reviewed scatter plots. And so now we get to actually put those together and come up with what we call a regression equation. So in this class, we're going to do just a regression line or a least squares line, regression line. And then we get to discuss other types of regression equations. So in this case, we call the regression line of data and the points on this line to give predicted values for the data. So essentially, the reason why we want a regression equation is to get a predicted value. So, just like our situation that we're in with COVID-19, we keep predicting that we're going to hit the peak, right? We're going to they predict this, right? And how are they getting those dates? Well, because of regression analysis. And then we're just going to touch a little bit on the surface with lines. But as you can see, like a lot of the data make different models. We have the bell curve, normal curve model, and that's because of prediction, right? And that's because they're taking all the data up until now to predict a future date of when we could, resume life as normal. And so if that behavior is changing with our community, um, like not social distancing or not just abiding by CDC recommendations, then that prediction with that date of when things could go back to normal is going to change because why? The current data is changing. And so it's just really important that we understand that regression analysis is within the scope of our model. So if we wanted to see what it's going to be like a year from now, that we cannot predict that at all because it's out of the scope of our data. Our data is up until now, which is May, and let's say they want to know what's going to happen next June. That is totally way beyond the scope of our model, and we would need to have a whole set of new data for other dates that are beyond our model. So we're just going to stay within the scope of our model, and we're going to only have lines here. But I mean, just to give you an idea of how this is used right now in our current situation, it's definitely, this stuff is being used. So we are going to predict using lines only, and so let's look how that would look for our data. So the least squares regression line, and otherwise known as best fit line, is represented as y hat equal b sub 1x plus b sub 0. So in 12.1, remember that we had a linear equation that looks like this. But now because b sub 1 is in terms of our data and b sub 0 is also in terms of our data, then we rewrite these coefficients as b sub 1 and b sub 0. Essentially, what does this mean? It means y sub hat is the predicted value. Okay, b sub 1 is the slope, and b sub 0 is the y-intercept. Okay, not to be confused with y. Okay, you're going to have a y hat, which is the predicted value. Y will be our observed values. So we may want to predict something, that'll be a y hat. But we said, oh, but it shows this at this time, that's the observed. Okay, and so we rarely compute this equation by hand. We always use technology, and please do. And how you find it is you got to enter the data, right? So you'll enter list 1 and list 2. You'll list your x coordinates in list 1 and y coordinates in list 2, and then you'll run a linreg test. So you're going to use the calculating menu. And I would use the ax plus b because b would be the y-intercept, and then a would be the slope. So b is like consistent of the y-intercept that we always know, and then a would be the slope. So let's go ahead and do that. The first thing we need to do is go to our calculator and select the catalog, second 0, and make sure our diagnostics are on. So if you took this class or some sort of statistics class before, you definitely would have already turned it on. So let's do that. Let's hit second 0. And we're going to go down to D, diagnostics. So scroll down. And you'll see diagnostics on or off. So make sure you turn it on so you can see that the arrow is there. It says diagnostic on. Hit enter. You'll see it on the home screen. Hit enter one more time and it says done. So as long as you see that word done, then it's good. Because what you're telling the calculator to do is like turn this stuff on because we're going to like crunch out some stuff here. Okay, now once you have done that, you only have to do it one time, and that's right now. And if you've done it prior, then it's already there on. But if you just want to, make sure you can do it now, and then that's it. It's fine for the rest of the semester. Okay, so now using the data from example 12.4, find the least squares regression line and draw it on the scatter plot. So 12.4 was the drilling rock example. So go ahead and input into the calculator. So put X in list 1 and Y in list 2. So let's go ahead and go to the calculator and go to Stat and go to Edit. And you'll see here I've already entered the drilling rock. If you haven't, go ahead and do that. And pause the video and enter. Okay, and then after you enter everything, you'll go back to Stat and go to Calc, and you'll see the good old list that we had before. And number 4 is ln reg ax plus b. So some of you may see down here in number 8, the ln reg a plus bx. This is a preference. It is not one or the other. I personally just like number 4 because B is the y-intercept in algebra and it's a B in statistics, and I just think that I'm conditioned with the letter B being the y-intercept, so I like number 4. So go ahead and select number 4 and enter, and notice that I have X and Y in L2. So my X's were list 1, my Y is list 2, leave freckless empty, and here you can go ahead and store the regression line. If you want to store it somewhere, we're going to store it over here. See how Y1 is empty? We can store it in any of these, but we can go ahead and store it in Y1. So if I go back to Stat, and then let me go back to Calc because I left that menu, hit 4. I have list 1 is my X's, list 2, freck list is blank. And to store the regression equation, just that equation of the line, we could go ahead and do that by hitting vars and then hitting y vars, which is up here. So move the cursor and it says function, so number 1, and then function 1. So that y1 is the same y and that y equals. So hit enter. You don't always have to store it, but it's good to store it if you're going to predict values later. And then let me go ahead and drag this over. Okay, and then let me hit calculate. And so it gives me all this information. So let me go ahead and drag that over. And we can see that the pieces that we need are that slope and y-intercept, right? So here's the A, which is the slope, and the B, the y-intercept. So M and then B. The R squared and R you see there is actually what we need for future examples in this section. So we'll just keep it there. And so it says find the least squares. So let me go ahead and say, okay, this means, so number 2, that means y hat, you have to put y hat. Y hat is equal to mx, so 0.012 x plus the b, which is 5.527. And the reason why I'm rounding to 3 decimal places was because if I go back up to example 12.4, Notice the number of decimals I had was 2 past the decimal, so therefore any rounding I do, it should be to 3 decimals. Okay, and so this is the line. Let me go ahead and box that. And that's the process. So you just put x's in list 1, y's in list 2, run a lin reg ax plus b, and write the equation down. And so then the next part would be is to actually draw the scattered line, this, the least regression line. So draw vy hat. And so just go back up to example 12.4 to draw it. Okay, so here, if I wanted to draw the line itself, so remember y hat was equal to 0.012 x plus 5.527. So that's the line we're going to draw. And so notice the first point on the x-axis is 20. So let's go ahead and put 20 in there and see where that point is. So this is where that y1 is going to come into tact, right? So click y equals now on your calculator and you're going to, whoa! Notice that that is the regression line that we stored. Nice, right? Okay, we're going to use this line to predict when the starting drilling depth is 20 feet. So hit second mode, which gives you to the home screen. And now what we do is we grab y sub 1 from that same vars menu. So we'll just hit vars, y vars, function, and then 1. So it looks like that on the home screen. And put a parenthesis of 20. Like just like that, right? Looks like f of x, right? Like a function. Hit enter and it gives it to you. It's so cool, right? And so now we know it's 5.75 or 76. So here I did an ordered pair of 20 and then 5.5. Let's see. 5.76. And so that will be 25.76, so about here. And then I'm just going to take another line of 190 starting drilling feet because that'll just give me the end point and I can just connect the two dots. So let me go back to the calculator and I'll do the same thing. I'll just hit second enter just like that and just put in 190. It's going to grab that same Y1. And that'll be 7.72. So 197.72. Like right here. So let me grab a line in my tablet and I'll just connect the dots like that. Okay, and so this is y hat, which is 0.012x plus 5.527. Okay, so the last thing I just want to mention is this warning symbol. It just says it's always important to plot the scatter plot first, right? Because if the scatter plot shows maybe like a parabolic relationship or a normal curve, right? The normal distribution relationship, then why would we even try to do a line, right? Like then don't do a line. So you need to do the scatter plot first and then draw the line and then see if there's a pattern to a line and see if this would be a good fit. If you think that it's a good fit and it follows the positively associated or negatively associated pattern, then run the Lin regression line. But however, if you don't see that it is, then there's no reason for it. And also don't forget that this regression line is only good for the scope of the model. Any x values outside this domain that was given to us in the data, you're risking it, and we're going to talk about that in a little bit. But 190 was the largest, right? Depth rock, starting depth, right, for the rock, and If we wanted to know what it looked like at 300 feet, that might be a little too far down and outside of our model.